Good evening, everyone. It's a nice evening. With the new year just around the corner, have you ever wondered what the future might look like? Not just here on Earth, but out there in the vastness of space? And what if I told you that one day humans might live on other planets, travel to distant worlds, or discover things we can't even imagine today? Let's take a journey together and explore the future of space holds for all of us. Let me introduce our esteemed speaker for today, Mr. Divin Raj. Divin is an aeronautical engineering graduate with a strong passion for space education. And over the past 2 years, he has been working with Navas EduTech, inspiring young minds and sharing his expertise in the field of space science. He also brings a solid background in UAV technology and has been a keen interest in rocket propulsion system. Additionally, Divin serves as a space lab educator at Delhi Public School, Miapur, where he continues to spark curiosity and innovation among students. With his dedication to fostering the next generation of space explorers, Divin is here to guide us through the future of space exploration. Please join me in welcoming him. And over to you, Divin.
So thank you so much, Ardi. Thank you for your kind words. Thank you for that heartfelt welcome. So hello everyone. Good evening to one and all. I hope all of you are doing well. I hope every one of you were waiting for that 6 o'clock to hit the clock, and you guys are here. So without wasting any time, shall we begin the session? Okay, so let me share my screen and we'll start the session very soon. So I hope my screen is visible to everyone. So you guys would already know what we're going to speak about today, right? We're going to discuss about the future of space exploration. Okay, we'll see how the future is going to look like. What is going to happen in the future? What type of technologies are going to come? What type of innovations are going to happen? Are we going to some other planet? Are we going to live there? So I'm going to answer all your questions today. And for the next 1 hour, we'll be having fun. We'll be learning a lot of things and it's going to be interesting. Okay, so before beginning the session, guys, please have a notebook or a notepad with you. There will be a lot of information coming up so that you can take a note of it. Okay, so now, before beginning the session, I have a small question to everyone. So on behalf of the whole Nawars team, we welcome everyone to this live session. Okay, so guys, are you really curious about the next step in space exploration? If that answer is a yes, we'll go ahead with so much energy, with so much enthusiasm. So what's your response? Is it a yes or is it a no? I can't hear anything. Be loud, guys. Don't think that sir can't listen to you. I can actually listen to you. Give me a positive shout out. I need a very powerful yes. Yes, that's the spirit. That's the spirit of all the space enthusiasts, right? So right now, we'll be beginning the session. We'll be exploring how we are going to explore space in the future. All right. So now, whenever we talk about space exploration, whenever you are listening to some news about a rocket agency or a private space company or a government agency launching some rockets or some satellites, or some spacecraft out there in space, there are certain people who will be wondering, why I have to spend this much amount of money just to build a rocket, just to launch a rocket, or just to launch a spacecraft? Why can't I use the same amount of money to solve the problems here on the earth, like solving poverty or building certain things or whatever it is? People may be asking, why you are spending this much amount of money? You're having a lot of money, you're just building rockets, you're just building satellites. You can't use the same money for some good things, right? If someone is asking you the same question again, don't stand without any answer. You have to properly give them an answer. Okay, you have to tell them step by step. You have to tell them one by one. Say, for example, we have a lot of satellites out there, right? You can see one here at my back. Similarly, a lot of satellites of different shapes or different sizes are orbiting the Earth, right? If these satellites are not there, or if humans have never ever thought of sending the satellites, do you guys think there is a use of the smartphone right now? Huh? Can I use it? Can I use Google Maps? Can I use my televisions to watch some TV shows, your favorite cartoons and all? Can I use can I use my mobile phone to call someone? No, right? We are dependent upon the satellites for a lot of things. Whenever there is a cyclone coming, whenever there is rain coming, all these things will be getting the warning from the space agencies, right? We'll be getting the warning from the weather department. Who is helping them? These satellites are actually helping them. All the satellites which we have sent over the years, they're looking into the earth over time and they are sending us this data, right? So do you guys think it is not worthy to send these satellites? Who is going to give us the information about the upcoming cyclones or upcoming rain or whatever it is? How you are going to call your friend? How you are going to watch your favorite cartoon, right? So satellites are very important. Similarly, there are a lot of technologies that came as a result of humans exploring space. Okay, space exploration is not just going to space and coming back. The technologies which we developed during that time will be useful after a certain period of time. Say, for example, you guys all would have heard of the scratch resistant glasses, right? Where, like, right now it's a trend. You have the sunglasses, and the companies will be saying it's scratch resistant, right? They'll advertise in the large banners, large taglines. Have you ever wondered when we started using these scratch resistant glasses? It all started back in the times when we started sending astronauts. Because the astronauts will be having the visor in their helmet, right? On the visors, we started using the scratch resistant materials, scratch resistant glasses. Later, that technology got adopted over here at the bulk use. Okay, so it all started from space itself. Your solar panels. Right now, every homes, every industries, they'll be using solar panels in large amount, right? But even though we have the idea of solar panels, we started using a large number during the space time of applications for your satellites, for your spacecraft. Once we started, once we got an expertise in handling the solar panels, we started using the solar panels abundantly in our day-to-day life. It also goes back to the space exploration times. Okay, so don't think that it's not just about exploring space. There are a lot of technologies that come as a result of space exploration. There's one more very important thing. You guys know that the earth is not the same as it used to be 100 years back or like 200 years back, right? Things are changing. We are polluting the earth. We are actually depleting the resources on the earth. The temperature on the earth is increasing. So earth is not a permanent solution for the long term, right? For the next 200 or 200, like for the next upcoming billion years or million years, we can't just live here, right? We have to become multiplanetary. We have to settle down in some parts of the universe, some parts of the solar system, correct? So Earth is not going to be the permanent home for us. We have to look for some other homes. So if you want to look for some other homes, you can't simply sit here and be like, okay, I have a home there. I have a home here. No, you have to go there and explore, right? If you're not launching the rockets, if you're not launching the spacecraft, how are you going to learn about all these worlds? Who is going to give you the data about all these things? No one, right? So you have to take the initiatives. That's the reason why we are spending this much amount of money to explore the space. So don't just again think that it's just about going there and coming back. It's actually serving a lot of other purposes. Okay, now guys, whenever we talk about space exploration, there are certain events in the history that happened which is so much influential or which is so much important when it comes to human space exploration. Okay, we started with if you guys see, we had the first satellite, first artificial satellite, right? Do you guys know the name of the first artificial satellite? Can I know the name of that first artificial satellite? Can you guys tell me the name of the first artificial satellite? Sputnik, correct. So Sputnik was the first artificial satellite which we developed. So it was developed by the Soviet Union during the 1957 during the Cold War time, right? So they sent the first artificial satellite to the Earth. It started orbiting the Earth, and this is the Sputnik 1. Okay. And similarly, the Americans or the United States of America, they replied by sending a human to the moon with the Apollo mission, right? Correct. So this is also a very big step for mankind. The first human on the moon. We have traveled from the Earth to a nearest celestial body. We have landed there safely. Correct. It's a very big leap for humanity. Just like your Neil Armstrong said, right? Similarly, You also have a member who is still traveling through the space. Okay, he started his journey like 47 years back in 1977. In 2024 also, he's still traveling alone in the darkness of space. No one is there. For 47 years, the spacecraft is continuously traveling. Can you guys guess the name of this spacecraft? Can you guys just put it in the chat box? Yes. Which is the spacecraft shown here? The farthest human-made object in space. Yes, your Voyager 1, right? Your Voyager 1 is also a very big, significant part of human space exploration history, right? Because just imagine for 47 years, something that is made by humans is traveling. It escaped the solar system. It's traveling through the interstellar space. It's a very big feat for us, right? It is not just about these three missions. I just picked up some of the important ones. If you guys see Chandrayaan 1, we detected water for the first time on the moon. Correct? We have done a lot of landings on moon. We have done a lot of landings on Mars. We have flown a helicopter on Mars. We have gone to Titan, right? So a lot of things have happened during these times. It is the past. But our focus is going to be on the future. What is going to happen in the future? What technologies are going to come? Is the human space exploration or the space exploration is going to be the same as it is happening right now? What are the developments that are going to happen? Will humans go back to moon? Will humans go to some other planet? Huh? Everything. All these things will be answered in the next 40 to 45 minutes. Okay. So right now we are going to explore the future. What is going to happen next? Right? So now, how we are going to explore the space? I just classified it into some parts, some types, and we'll explore them one by one. So firstly, I can like observe the space, correct? I can put some space telescopes. I can watch how the space is, where are these planets, where are these exoplanets, where are these distant galaxies, just like how your Hubble Space Telescope is doing. Can you guys guess the name of the picture shown here? What's the telescope shown here? Yes. What's the name of this telescope? Your JWST, your James Webb Space Telescope, correct? Your answer is right. So JWST is also a space telescope. So these things are observing the universe continuously, right? They're clicking the pictures, we are analyzing the pictures, we're getting a lot of data about it. The universe, how it is behaving, or how all the mysteries that your universe is holding on to, right? So observation is one thing through which you can see how the universe, or you can explore the universe using observations or using telescopes. Now comes the most interesting part, where I want to observe a distant planet or I want to go and explore a distant place, but the next day I can't pack my bags and go over there, right? Will you go? Okay, someone is coming to you and telling, tomorrow, just go to Mars. I'll send a rocket for you. I'll prepare a rocket for you. You have to go to Mars the next day. Will you go? Without thinking anything, without asking anything, without getting any data, any training, any exposure, nothing. Can I simply go to Mars? Just like how I go from here to my school or from here to my friend's home. It is not that simple, right? You have to sit in the spacecraft for a long time. You have to face those psychological and physical problems, challenges, and everything. So it's going to be very difficult for humans to explore. In those cases, we have came up with a small solution. Instead of sending a human, why can't I send a robot instead? Right? Why can't I send some machines instead? Right? Because you just have to make the machines perfect. Then you can send it. It will explore all the distant parts of the space, and you can get the data. Okay, so we have landers, we have rovers, we have spacecraft, a lot of things are there. We'll explore them in detail. So now observations, robots. Third, as you have guessed, humans, right? I want to go to a place. I want to feel that place. I want to experience the place in real. I have to go there in person, right? So there comes the need for human space flight. We will send humans to study the place. Okay, so these are some of the ways in which we are exploring space right now, and we are going to explore the space in the future too. Okay, now let's break down them one by one. Let's see what are the missions that are coming up in the future from all these categories. From telescopes to spacecraft to landers to human missions, we'll explore them one by one, right? So first thing first, what do you understand by this picture? There's a picture on the left hand side. It's very beautiful. Just see this picture and tell me what you understand by this picture. It's a telescope. It's a space telescope, correct? Right. Right now, we are having a space telescope, or we are having many space telescopes, out of which you guys would have heard of a telescope called the Hubble Space Telescope, correct? The Hubble Space Telescope have taken the most of the images which you are seeing about the space. Whatever it is, whether it's a galaxy pictures or some distant planet pictures, most of these pictures would have been taken by the Hubble. Okay, now 3 years back, we have launched a telescope that was claimed to be the successor for Hubble, your JWST. Okay, but if you see the astronomers are so much eager for the launch of a different telescope, which they consider to be the exact successor for Hubble. And that one is your Roman Space Telescope, or the Nancy Grace Roman Space Telescope. Okay, so this is not a telescope which we have launched. It is going to be launched for 5 years from now. So we are expecting this telescope to be launched by 2027. So NASA is going to be the operator. Now the interesting thing about this one is that, you know Hubble, right? The Hubble can take a lot of pictures, right? The good thing about the Roman Space Telescope is that in a single look, okay, in a single observation, this telescope can cover like 100 times more area than your Hubble. So the field of view of this telescope is even like 100 times bigger than the Hubble. So it's going to take more wider images of the space. Okay. And what we are going to do with the telescope is that we are going to learn about dark matter, oh, sorry, dark energy using this telescope. You guys know, right? Our universe is expanding at a very high speed, right? And the reason for it is dark energy. And still, it's kind of like a mystery for the scientists. We have to learn about it. To learn about it, this telescope can actually help you. You know how? This telescope is going to take, I told you now, this is having a very wide view. This can scan like wider images of the universe. So what we're going to do with this one is that we're going to make a 3D model of the universe. So we'll scan into a particular area right now, then this much area. So we'll completely get a 3D model of the whole universe, and we'll analyze it to see the rate of expansion, how much it is expanding. Okay, so this telescope is actually named after one person, one very significant figure. So her name is Nancy Grace. Okay, so she is one of the first chief of astronomy of NASA. Okay, this happened during the 1960s, and she was also an astronomer. She was having a good background in astronomy. And the first project, or some of the projects which she worked on initially, were a telescope. Okay, at that time, NASA was having a plan of building a space telescope, or to build a large space telescope. This large space telescope eventually turned into a Hubble. Okay, so she was one of the driving forces behind that telescope, and that's the reason why she's also called the mother of Hubble. So Nancy Grace is actually called the mother of Hubble, and there is no other better person, or there is no other name which we can use for a successor for the Hubble, right? You're building the successor for the Hubble. You can't come up with some other names, right? Because she's the most appropriate person. She's the mother of Hubble. So we named it as the Nancy Grace Roman Space Telescope. Okay, so this is one. This is by NASA. It is expected to be launched in 2027, and we'll be using the Falcon Heavy rocket. You guys know Falcon Heavy, right? By SpaceX. So we'll be using Falcon Heavy rocket to launch this telescope. Now, coming to the next one of the biggest achievement which we are going to have in the future. This is a mission by European Space Agency. The good thing is that this is going to be the first ever space-related gravitational wave observatory. Because we have certain gravitational wave observatory here on the Earth. You have in USA, you have one in Italy. Okay, so this is going to be the first space-based gravitational wave observatory. Now you guys may wonder, what do you mean by gravitational waves? Okay, I'll give you a small example. You all would have played this game, right? whenever 1 minute, guys. Whenever you are going to some places, whenever you're going to some lakes, you have the habit, or we have the habit of throwing stones to the water, right? We'll be throwing stones just to see the ripples coming out, right? We'll see the waves coming out, waves emanating out, correct? Similarly, in space also, these waves will be created. You know who is going to create these waves? We have very violent activities that will be happening in the space. Say, for example, two black holes merging or some neutron stars colliding, whatever it is, whenever there is a violent activity, violent phenomenon happening in some parts of the space, it will send these waves through the space. Okay, so these waves are actually called the gravitational waves, and this one by ESA is specifically built to measure, to detect the gravitational waves. Here you guys can see here, there are three spacecraft, guys, and these three spacecraft will be flying at a constant speed, at a constant distance from each other. They're not going to fly at different speeds, at a constant speed and at a constant distance. They'll be flying, they'll be maintaining it. And you can see that they'll be shooting lasers at each other. Okay. And by analyzing this, if there is a gravitational wave hitting, you will get variations and you'll be able to detect it in space itself. Okay, so that's the use of this LISA telescope. Okay, so the LISA telescope is one of such gravitational wave observatory which we are going to have out there in space, and it is going to be happening 10 years or 11 years down the line. We are eagerly waiting for it, to be honest. Okay, so let's wait for it. Let's see how it is going to happen. So the good thing about this one is that, guys, if you see here, I told you this is by ESA, right? European Space Agency. The good thing is that here ESA is collaborating with NASA for this project. Okay, so earlier times, if you guys used to see, there's actually a competition between these space agencies, right? Like during the space war or the Cold War time. Now even the countries are collaborating. 2 weeks back, ISRO launched two of ESA satellites, Proba 3, right? It was a mission by ESA, and we launched their satellites. Okay, that's a collaboration that is happening right now in the industry, because we, at least for the fact of space, humanity is together. We are working together. Okay, so that's really good thing when it comes to space industry. Okay, so now whenever there is some gravitational waves coming, you'll be able to detect it. Now you guys may wonder why we have to detect gravitational waves. Okay, just I'll give a small introduction about it. Whenever you guys are seeing something like some planets or some galaxies, you're seeing it because light is falling to your eyes. Correct. Now, what if there are some events happening out there, but no light is coming out? We won't be able to detect it. We won't be able to see it correctly. Yes or no? You will only be able to feel it in the form of gravitational waves. Just like in the case of black holes, because you guys know black holes, from the black holes, not even light can escape, not even light can come out. So it'll be very difficult to see them. Okay, so we have to detect them. So we'll be using gravitational waves to detect them. Okay, so this is about the LISA. Okay, so I hope this was clear for you guys. Now we'll go to the next part. Okay, so I want to explore a distant planet or a distant world up close. Okay, without just observing, I want to go there and observe. What should I do? Or what type of things I should create? Yes, put down your answers in the chat box, guys. Yes, what do you think? How we are going to explore the distant worlds? Okay, you can use robots. Your answer is correct. You can use robots. Okay, when it comes to robots, there are certain things which we can do. All right. So you would have heard of landers. Huh? Here I have a lander with me. I hope this is clear for you. Here I have a lander. This is one of our lander, which is called the Navic lander. Okay, so this is Navas Vikram lander, which we have built. More onto it later. I will explain the components to you when we are talking about landers. Is lander the only type of robots which I can send? Is there any other robots which I can send? I'll get one. Meanwhile, you guys find the answer. Okay. Can I use these things? Can I use these things? What are these? Yes, they are called rovers. Exactly, guys. We have rovers, right? During Chandrayaan 3 also, we have sent the Pragyan rover, right? Similarly, we also have a lot of rovers out there on Mars. So you can send a rover. The rover will be slowly moving on the surface. It'll be getting information. It'll be doing the scientific research over there, and you can use that data. So instead of sending a human to Mars directly, we can send some landers. We can send some rovers. Now, I can also send some spacecraft. Correct? Say for example, we have the Cassini, we have the Voyager, or we have the like a lot of spacecrafts are there, right? These spacecraft can carry humans. It can also be autonomous where they are not carrying any humans. So spacecraft is also one way through which you can explore, right? Then you have the space probes, which will be going to very far away places without any human help. It is going to be completely autonomous. You would have heard of the Huygens probe, right? The probe that went to Titan. Correct. It's an example for probes. Now let's explore them one by one. We'll go to landers, we'll go to rovers, spacecraft, and see what are the future missions that are coming up. All right. So now, first of all, we'll go to landers. You guys know what are landers, correct? Even if you don't know anything about landers, you would have at least heard of the Vikram lander, correct? Your Vikram lander will look somewhat like this, correct? You'll be having the opening. Your lander will be opening. From here, the rover will be coming out and will be slowly roving on the surface of the moon. So this is one of our lander. Here, you'll be getting the data about temperature, the pressure, and everything over here on the display panel once you're connecting it. Okay, so now see what are the future lander missions that are going to happen. Okay, whenever I say about landers, whenever I say about Pragyan or whatever it is mostly related with some or government agencies, right? You may think that either it's by NASA or either it's by ISRO or JAXA or Roscosmos or ESA or any space government agency. But right now the things have changed. This year, we had the first private company or the first private landing on the moon. Okay, so this year we have the first private landing on the moon. Now we are going to take the things further and we are going to have the next private space landing. Okay, it is going to happen very soon and the name of the mission is Blue Ghost 1. Okay, you can expect this mission next month probably. So this is going to happen and it is by a space company called the Firefly Aerospace. Okay, so this one is having some scientific instruments, like nearly 10 scientific and technological instruments. It is going to study the moon. Okay, and you guys know about the moon, right? The moon holds a lot of mysteries, right? So this one, your Blue Ghost one, is going to be operating on the moon for 14 Earth days. 14 Earth day equals to 1 lunar day, correct? So it is going to operate for 1 lunar day and after maybe some hours after the sunset, it is going to capture the picture of the sunset and it is going to get some data about your moon. Okay, so we are going to launch it. SpaceX is going to launch this one. So what is going to happen with this one is that just like how the Chandrayaan 3 did, it is also going to take some time to orbit the Earth. So 45 days, it is going to be it's going to be in transit. It is going to get the data. It is going to check whether all the systems are working properly. Okay, so just for example, imagine this as your lander, sorry, this as your orbiter. You're going to orbit the Earth. Whenever you're orbiting the Earth, you will check whether all your things are working properly, all your subsystems are working properly, and then you will climb to the higher altitude slowly by slowly. So 45 days, your blue moon or your blue ghost is going to be in journey and it is going to reach the moon. Okay, and it is also going to land in a place called the Mare Crisium. Okay, so it's going to land in the Mare Crisium. Now, let's see one rover. You guys would have heard of Perseverance. You guys would have heard of Opportunity, Spirit. A lot of rovers are out there on Mars. Now, let's see the future Mars rover, which is going to be launched soon. Okay, so it's called the ExoMars rover. Again, it is by the European Space Agency. Okay, so ExoMars Rosalind Franklin rover, it's going to be launched by the European Space Agency in 2028. So hardly 3 years from now. So what happens is that before this one, guys, I have to tell you one very important thing. Okay, so see here, this Rosalind Franklin is a person. Maybe you would have heard of her in your biology classes. How many of you have heard of Rosalind Franklin? She's actually the person who helped us in understanding the structure of our DNA. Okay, so to honor her, the next Mars rover or the first European Space Agency's Mars rover have been named as the ExoMars Rosalind Franklin rover. Okay, so the primary mission of this one of your Mars rover is basically to detect for the any sources of life on Mars, any tiny form of life on Mars. Okay, because you guys know there are a lot of theories that states that Mars was a place that held life for a long period of time, and it vanished eventually. So this rover is actually aimed at finding or founding any traces form of life, like any trace of life. Okay, so those signatures of any signatures of living organisms is going to be detected by this rover. And if you guys see here, what it is going to do is it is going to drill the ground basically. Okay, you're going to drill the ground up a height of like or to a depth of 2 meters, which is by far the most like you haven't tried that much height or that much depth till now. So it is going to drill till 2 meters. It's going to collect the samples. It is going to analyze those samples. Okay, if you guys see here, it's very interesting. It is basically like a mini laboratory on the wheels. They have a mini lab on the wheels. Okay, so it's that huge. It is going to find the traces of life on Mars. And if you guys observe here, it's also having a panoramic camera. You would have heard of the panorama, right? Panorama where you get a wider picture in one click. Similarly, this is also going to take the image of Mars using the camera. So the scientists can look for some interesting places or interesting sports or some interesting information about the surface of your Mars. Okay, so this is going to be Europe's first attempt to land on Mars with a lander. Now, it is going to study the Mars atmosphere, the Mars soil, and also in like to look for any traces of life, Indian life. Okay, so this is the landers and rovers, some of the very important landers and rovers that are going to happen right now in the 2020s, in your 2020s. Okay, so 4 years or 5 years down the line, these two missions are going to happen. Now, guys, whenever I'm talking about landers, something is going to land at a particular place. Correct. And if you guys see, I'll just show you the lander again. If you guys see, whenever I'm speaking about lander, this will be the first picture, or this is the real shape of a lander that will come to your mind. Yes or no? You'll be having some solar panels, you'll be having some science instruments, you'll be having the thrusters, right? So you'll be having the landing legs, the most important one, right? So this is the picture of the lander that comes to your mind. But I'm going to show you one lander which looks that it is coming directly out of a sci-fi movie. Okay, so we are going to see that lander right now. It's not a proper lander. It is having different name. It's a rotorcraft. I'll tell you what it is. Okay, nothing to worry. So it will look somewhat like this. See the design. It looks very crazy, right? And it resembles the dragonfly in the design. So we are actually calling it as the NASA's Dragonfly mission. Again, 2027, 3 years. So 2028, 2027, that time is going to be the peak time. A lot of missions are coming up, right? Now you guys got an idea how many missions are coming up during these small timeline. Correct. So now just look at the background here, guys. Just look at the background of your rotorcraft, your lander, and tell me what planet or what celestial body this is. Just put your answers in chat box. Just by seeing the picture, is it resembling some celestial body, guys? Which you guys already know. Yes, Mars. You guys told Mars, right? But the cool thing is that it is not going to Mars. It is going to one of Saturn's biggest moon, the Titan. Okay, because you guys would have heard of Titan. Titan is a place that have lakes. Titan is a place that have a very thick atmosphere. But the lakes are not made up of water. It is be made up of methane. That's the difference. Okay. So this is unlike the traditional rovers or unlike the traditional landers. The good thing about this one is that you can go to multiple places. Okay. Just for example, if you are sending a rover, okay, you're sending a rover to a particular place, the rover will be moving very slowly only. You would have noticed it, right? The rover won't be moving at like 70 km per hour or 80 km per hour. It'll be moving very smooth, like it'll be moving at a very low speed, slowly, right? So the area your rover can explore will be also limited, right? It's not that big, correct? Same as for your lander. Once your lander is landing at a particular place, once it lands at a particular place, it'll be using its equipment to do the research in one small area, correct? So there's a limitation for us, right? Now, with this mission, with the Dragonfly mission, what we are going to do is we're going to take things to the next level. We're going to explore Titan, or we are going to explore the celestial body in a different way, like we have never ever explored. Because this lander or this rotorcraft, why I call this as a rotorcraft is because, can you guys see the rotors here? It is also having rotors. Okay, so if you see, it have 8 rotors. So as pairs will be there. So this rotorcraft is capable of flying like for like very huge distances at a very tremendous amount of speed. So you're not just forced to be on a small amount of area. You can go to large areas. You can go to very distant places. Okay, so this is going to be the first mission where you are going to multiple places in a particular celestial body. Okay, you can explore a large amount of Titan because Titan is having a lot of hydrocarbons. Titan is having a lot of methane. It's having a very thick atmosphere. So we believe that Titan can actually give us a lot of idea about how life would have started here on the Earth. Okay, because we believe that Titan actually resembles the early Earth, the Earth that existed like some billion years. Okay, so the early Earth, Titan is also having a resemblance. Just to study that particular place, we're sending this particular dragonfly, not dragonfly rotorcraft. It's a lander, it can land, and we are going to get the data from it. Okay, so this is going to be the first mission that is going to fly to multiple locations. So it is having that speciality. Okay, very interesting, right? The good thing is that now you guys may wonder how this is going to fly in a different planet. The thing is that your Titan is having a thick atmosphere, so you have sufficient amount of air for your rotor to like push downwards. Okay, and gravity is also very less, right? So it's one of the most suitable places. Okay, so we hope to send this mission by 2027 or 2028 and to explore the Titan deeply. Okay, now how I can travel to very large distances to explore new spaces. Any idea? I can use spacecraft. Very good, right? So this is actually a mission. Okay, this is a mission by a company called Rocket Lab. And here you can see there are twin spacecrafts. Okay, so this escapade mission is by a company called the Rocket Lab, and they are going to send 2 identical spacecraft. One is called Gold and one is called Blue. And just by looking into the planet, you guys got an idea which planet that is, correct? It is going to be your Mars. Okay, so this is aimed to study the magnetosphere of your Mars. Or you guys know every planet, most of the planet will be having the magnetic field, right? Your Mars also have a very weak magnetic field. Now you have the sun. From the sun, a lot of charged particles will be coming. We call them as the solar wind. Okay, this mission is aimed to study how this solar wind is basically interacting with the magnetic field of your Mars. Okay, because we know Mars have a very thin atmosphere, but earlier Mars used to have a very thick atmosphere. So our main aim is to study how Mars loses that atmosphere. Okay, so this mission is going to do that, escapade mission, and it is also going to happen very soon by Rocket Lab. Okay, Rocket Lab is also a private company, by the way. Okay, so things are changing. Not only government agencies, private companies are also doing great things. Now, talking about India's attempt for a spacecraft in 2028, guys, 4 years from now or 3 years from now, we are going to launch a mission called the Venus Orbiter Mission. You know a different name of the same mission, the Shukrayaan mission, right? Just like how we have the Mangalyaan, the Mars orbiter mission, here you have the Venus orbiter mission. You guys know about Venus, correct? Venus have a very thick atmosphere, correct? Back in the days when we started exploring Venus during the Venera missions, we identified that The atmosphere of Venus was so thick that you don't have to use any parachutes. The atmosphere itself will slow you down if you try to touch down on the Venus. Okay, so this is not going to land there, it's going to be an orbiter, and this is India's first attempt to Venus. Okay, this is aimed to study the atmosphere of Venus, the surface of Venus, how Venus is having this much toxic atmosphere, right? Venus atmosphere have clouds of sulfuric acid. It rains sulfuric acid there. Yes or no? It is having a lot of carbon dioxide, a lot of greenhouse gases. Your Venus is so much hot. Yes or no? So to study that, India is also sending a mission, which is called the Venus Orbiter Mission. We also call it as the Shukrayaan mission, and it is going to happen in 2028. Now, can these spacecraft help us access the resources which is present outside the Earth? By resources, I mean minerals or anything that can actually help you. Whatever resources you have here, like metals or non-metals or water. Similarly, if these resources are present in some other part of the solar system, can I use the spacecraft to get them? Can I use the spacecraft to access them? What do you guys think? Yes, the answer is a yes, guys. I can use that to access these minerals, to access these resources. You would have heard of something, a very innovative, very sci-fi idea where you're going to an asteroid and you're going to get the minerals or get the resources from there. It's called asteroid mining. Okay, just like how we mine here on the earth and get valuable resources like gold, silver, etc. These resources are also present in the asteroids out there. It's just a matter of time that you have to go there and you have to get the resources. If you think that we have never ever done it, I'll tell you about a mission that happened recently. You would have heard of the OSIRIS-REx mission. It have traveled to an asteroid called Bennu. It got the samples back. It returned back to Earth after a journey of 7 years. Okay, that much big we have achieved. But the thing is that even though it is having a wide, like abundant supply of resources like your gold, platinum, silver, your water, your metals, everything are present in the asteroids. So whatever we consider rare here on the Earth, we say that gold is rare, silver is rare. But if you go out there in space on these tiny, tiny asteroids, you have abundant supply of them, a large supply of them. You just have to go there and mine them. One more thing is that, guys, if you see, we are not just planning to go to Mars, or we are not just planning to stick on to Venus or to Moon, whatever it is. We also have the plan to expand ourselves, right? To go to other parts of the universe. Yes or no? So now, if you want to go to travel so much farther, you need fuel, right? Huh? In space, you don't have any stations, any fuel stations, just like how we have here on the Earth. Yes or no? So if you can build some stations here, it can act like a stop where you can stop there, you can get some resources, you can fuel your rockets or your spacecraft, you can start your journey from there. So deep space missions can also be used if you're properly utilizing the resources on asteroids. Okay, so we can't say that these resources limitations are preventing us from exploring the space. We have plenty of resources. Just use the right technology to utilize it. That's it. Okay. Now, guys, till now, robots have actually helped us in understanding the universe a lot more. But it's time for humanity to go back, make history again. Right? You guys know what I'm speaking about, guys. Right? How is humanity going back to moon? How we will go back to moon? How that happens? When it is going to happen? We have done the Apollo missions, right? During 1968 to 1972, we have launched like more than 12 astronauts to moon, right? So 6 to 9 missions have happened. Now it's the time for us to go back to the moon, right? Because 50, 60 years have passed by and we are still stuck here on the earth. It is not very good for a civilization like us. We have to do a lot of great things. We have to go back. To go back to the moon, the mission that is going to happen is called the Artemis mission. Just like your Apollo mission, this is going to be the mission that is going to take back humanity back to the moon. Okay, so this is by NASA. And if you guys see here, they have built the rocket for it. So back in the Apollo times, you had the Saturn V. which was even taller than your Statue of Liberty, which was one of the tallest and the most powerful rocket ever built at that time. As of now, also, it will come in 2 or 3. Okay, so this one is called the Space Launch System, SLS. Okay, and if you can see here, like if you completely fuel the SLS, it'll be carrying a weight of nearly 6 million tons or 6 million pounds. 6 million pounds will be the weight. So you guys know, right? If you guys have a rocket, most of the part of the rocket will be fuel, right? You can see the fuel and you can see the oxidizer here. Most of the part of a rocket will be fuel. Like most of the part, like 95 part, 95% will be fuel only. And a small portion will be there for your payload, whatever you're carrying, whether it's a satellite, whether it's an orbiter, or whether it's a human. There'll be small space left for them, but most of the part of the rocket will be fuel. Okay, so your SLS is going to weigh about 6 million pounds. Okay, and you are going to do this with the Artemis 2 mission. So Artemis 1, it's already done. Now the Artemis 2 is going to happen. And for the Artemis 2, we have developed the Orion capsule. Okay, so there is this Orion capsule which we have developed. And inside the Orion capsule, you have these 3 parts. One part is missing here. So you have 2 parts here, which is your crew module and your service module, just like how you had with the Apollos. Okay, so you have the crew module where the crew will be sitting. You have the service module, which will be providing the resources, the propulsion, the avionics, everything will be here. Okay, so this is going to happen very soon. And do you want to meet the people who are going back to the moon right now? Just like you had the Neil Armstrong and all those people who went to the moon. This is going to be the Artemis crew. One cool thing here is that you have Christina Koch. She's the first lady to go to moon. Okay, she's going to become the first lady on the moon. So we have the first man on the moon. So she's going to become the first woman on the moon. So her name is Christina Koch. Okay, and this is the Artemis crew. It's going to happen very soon. Okay, now you may wonder, okay, Artemis is there. It is happening in the United States. What about India? What we are going to do with humans? Right? At least some of you would have heard of India's human spaceflight program, right? India's big leap into human spaceflight. Yes or no? The Gaganyaan mission, right? The Gaganyaan mission is going to happen right now. All the training is happening, all the testing is happening. So this is going to be your crew module and your service module for Gaganyaan mission. Okay, so together we'll call it as the orbital module. Okay, together we'll call it as the orbital module. And can you guys guess the name of this rocket? It's very famous. It's not Chandrayaan 3. The name of the rocket is LVM-3 or GSLV. Okay, so since you are carrying humans, we had to actually modify the rocket so that it is capable of carrying humans. So you can see here, you have a launch abort system, you have your crew module, you have your orbital module, together. Okay, and you just modified your GSLV Mark III and you converted it into HRLV or Human Rated Launch Vehicle. Because you can't directly send a human in any random vehicle. You need proper approvals. You have to show them it is capable of carrying humans. Your engine should be powerful. Everything should be powerful. So this one is going to carry our humans because you guys know GSLV is one of the most trusted, one of the most reputed rockets of India. Right? It's called the Bahubali of India. Correct? It's so powerful. So it's going to carry the humans to or Indians to space. And the crew of Gaganyaan was actually revealed back in February this year by our Prime Minister. So these 4 people are going to represent India. They're going in an Indian rocket to space, to an orbit of 400 kilometers to lower Earth orbit. They're going to stay there for some time, 3 days. Then they'll be coming back. They'll be landing in the ocean. Okay, so all 4 of them are people from the Indian Air Force, from the defense side, from the defense sector. You guys know, right? They'll be properly trained. Every day they'll be trained to face all the hard challenges. Now they are the best ones which we can choose for missions like this, right? Because on their shoulders, the dreams of 140 billion or 142 billion Indians are. Correct. We are all dreaming for this moment when an Indian person is going in an Indian rocket to space. Rakesh Sharma is the first Indian to space, but he went in a Russian rocket, right? Soyuz. Correct. Here you are going in an Indian rocket, a rocket that is built in India. And these four people, three of them will be going, and that will happen very soon. Recently, also the testing is happening. They're testing the your modules, your lander modules, your crew module, your service module, everything, because it will be splashing down in the ocean. So you have to try it multiple times, whether it's strong enough. It will be protecting the astronauts. You'll be having the parachutes also, guys. I'll be having two parachutes for the crew module, but one will be sufficient for you. One is a backup for us. So parachute, all these testings are happening right now. Okay, so this is Gaganyaan. This is India's leap to human spaceflight program. Now to achieve all these things, to send a spacecraft, or to send a lander, or to send a rover, whatever it is, you need someone who is so much powerful to escape the Earth and take you out there. Yes or no? Who have that power? Who have that power? Yeah, who can say I have the power? You have to come from here because your earth, when you try to just throw this thing upwards, okay, even if you try just to throw a small ball upwards, it will come down. Because your earth will literally pull to it, right? The gravity will be pulling it down. Now you are sending something that will be weighing tons out there in space. Correct? So they have to be that much powerful, guys. And which vehicle can I use? Who's having that much power? Train, bus, car, airplane, whatever it, what is that? Yes, it's going to be rockets. Only rockets can achieve it, right? Only these giant flying machines can achieve it. So now we are going to meet some rockets, but these are not the rockets of the present, these are the rockets of the future. So whenever I'm talking about the rockets of the future, I can't skip this one, the Starship by SpaceX. This is the tallest and the most powerful rocket ever built by humanity, guys. I told you Saturn V, SLS, it is even taller than your SLS and your Saturn V. Okay, so this is built by SpaceX. The good thing about it is that SpaceX have actually developed some engines which are so much powerful because your entire thing is so heavy. You have to lift that much thing to space. So you need that much powerful engine, right? If you see here, this is not just a flower. It looks like a pattern, but these are the engines. They're called Raptor. Just see the picture where 33 of the Raptors are burning simultaneously or continuously. Just see the sheer force coming out. Just see the power coming out. See here the flames. This is enough to lift your Starship. 33 of the most powerful engines which we have ever built. They will be working together to propel your Starship. Now the cool thing is that your Starship have two parts. Okay, so I'll just come to the parts in a while. So if you guys see here, this one itself is called the Starship. This one is called the Super Heavy Booster. So both of them are actually reusable. So both of them will be coming back to the Earth. They can use it again and again. So multiple launches can be done. So it is reusable because in these rocket slides, I'll be showing only reusable rockets. There are tons of rockets, Indian rockets, Europe rockets. But I'll be showing the most successful or the things that are progressing at a very high speed. Okay. So the good thing about Starship is that Starship is capable of returning back to where it is launched, returning to the launch pad. So let's watch one video, guys. Let's see how the Starship is going to come and land over there. Okay, give me 1 minute. So if you guys see, Starship can come back to the launch pad. Why, guys? Why do you think why we should take it back to the launch pad? Is there any use from it? Huh? Because we can just make it fall to the ocean and just recover it from the ocean itself, right? Why we have to make it land at the same place? There is certain important things, guys. So let's watch this video. We'll watch one of the most important events that happened recently. It's a Starship booster catch. Yeah, booster catch. Okay, the sound is very high. I just reduce the sound. Okay. See here, the super heavy is coming down. See the speed with which it is coming. 15,000 kilometer per hour. 15,000, something that is so much heavier. It's coming down at a speed of 15,000 kilometer per hour and you're trying to catch it. This is some chopsticks. See here, okay. So now three Raptor engines will be firing. It's going to be grabbing the chopstick. See here. See, this mammoth, that giant object is literally held in the hands. See, see here, the whole world celebrated, guys, because this is one of the most important events. You literally catch something that is coming at a very high speed, and you literally made it stand there. See? This was the preparation that happened in SpaceX. Okay, so this is your Starship. Now, we're not just stuck with the Starship. Let's see a few more rockets. So we'll see a few more rockets and let's see how they are different from Starship. Now I'll introduce you to one of the rocket by Space. It's called the Nova. Okay. To understand Nova, I'll show you how much groundbreaking idea Nova is using. Okay, so let's watch the video of Nova. Let's watch how the Nova actually works. Okay, so I hope the video will be visible for you. So it's by a private company called Space. Okay, they are building one of the most innovative, groundbreaking rocket which we have ever flown. So we'll see how this rocket is going to work. Okay, so we'll start from here. So your rocket have two stages just like a Starship. So once it reaches the space, see here, what is going to happen? So Nova will be going to space. Our second stage is going to get separated. The good thing is that both of them will be returning back to the ground. We're not just throwing it in the ground. We're not just throwing it in the oceans. We're going to recover it. It is going to come back on the ground. Let's see here.
Is one to provide ultra high in space performance. Our payloads win.
So it will deploy the payload. If you have a satellite, it will deploy the payload. Now see what is going to happen.
That begins atmospheric re-entry.
That's the heat shield which is going to protect your rocket. Second stage. It is falling at a very high speed, coming back, coming down. See, this is very crazy, guys. Again, sci-fi scenes are going to happen.
Our heat shield leaves the vehicle at a low, approachable temperature.
Earlier, we never have this habit of recovering any rocket parts. SpaceX started recovering the first stage. Now, companies like rockets like Starship, Nova, they're recovering the second stage also, which is very difficult. That means you are not wasting any part of the rocket. You are recovering both of them back, put the load in it, put the payload in it, you are again launching it. Just like how your airplane is going to fly with the passengers. Again, will be coming back at the airport, again, will be going back. Similarly, we don't want like a lot of time between multiple launches. We want the launches to happen simultaneously. So reusable rockets, not just reusable, rapidly reusable rockets are going to be the trend in the future. Mark my words, guys. I'll just show you one more words with this, one more rocket. And with this, we'll wind up the session, guys. This is also very important. And again, it is by the company which I told you before. It's a company called Rocket Lab. I told you about Rocket Lab, right? Your escape mission. So same company is manufacturing a rocket called a Neutron. Similarly, you can see here, Neutron is not throwing the fairings. You have the fairing on top of your rocket, right? Usually what happens, it gets separated. It will create space debris. It can be a debris. So what happens is that it is not wasting the debris, not throwing away your fairing. It will open up. It will throw your satellite, your payload, or your second stage. This is called the second stage or the kick stage. It will be closed. It will be coming back. It will be landing at the landing site. Now again, what do you have to do? You don't have to do anything with this one. Just fill your rocket with the payload. Again, it will be ready for launch. So just like their CEO, Sir Peter Beck, his name is Peter Beck, just like how you have Elon Musk, he told that this is the rocket. This is how a rocket should look like in 2050. That is the ideology behind them while designing this one. And they are actually making it in 2 years. This is going to be reality. The testing is happening right now. The good thing is that this is very lightweight, because lightweight materials are going to be the trend in the future. This is made by something called carbon fiber. Okay, for carbon composites, it is going to be very lightweight. So if you have a rocket here on some rollers, I can just use one of my hand to move this giant rocket. Okay, so that much lightweight this is. Now with this, we'll wind up. So the next great discovery can be yours, guys. It's just a matter of time. It's just a matter of effort. And are you guys ready for it? If your answer is yes, we'll see who we are. Okay. You are taking sessions, you came for the session, you came for the Nawars session. Let's see who Nawars actually is. Okay, so this is our website. You can search here. So Nawars, basically, we are a team of passionate astronomers, aerospace engineers who are trying our best to promote space education in India. Because in the future, aerospace or astronomy is going to create a lot of job opportunities in India. Our country or the whole world needs a lot of skilled aerospace engineers or skilled astronomers or skilled space scientists. Because you guys know what are the missions that are coming up, right? So we need a lot of labor, a lot of scientists to work on these machine or these innovations, these missions. So we started educating students from K-12 segment, from grade 1 to 12. Okay, so we have a lot of space labs, more than 150 space labs across India. So in schools, we set up the space labs and we'll be having separate curriculum for online, for offline sessions. If you guys are not having your space lab in your school, you can actually contact here and you can be part of our online sessions. You can join here, you'll be learning a lot of things. It's not just learning theoretically, you'll be building things and learning. That's a good thing about here. You'll be building rovers, you'll be building landers, you'll be building CubeSats like this, the small satellites like this. All these things will be done by yourself. So it's basically an experiential learning. You are experiencing, you're building things, you're building projects, you're doing research, and you're learning. Okay, so you can come here if you want any course which is aligning with your grade. You can come here, you can opt for the course, you can get in touch with our team. So this is how one of our space lab looks like. Okay, so we have our educators in different parts of India. Okay, from North India to South India, we have a lot of space labs. And these people, we are actually training students about aerospace or space science or astronomy. And we are also ISRO certified space tutor partner. So that's also one thing about us. We are also part of the ISRO space tutor partner program. We'll be having a lot of DAV kits ranging from satellites to rockets to ancient astronomical sundials, telescopes, a lot of things are there. So if you guys want to be part of NAVARS, if you guys want to be part of NAVARS space program, if you guys want to be the next generation of space scientists and to help these missions that are going to come up or the future missions that are going to be there, you can be in touch with our team. You can contact the team. Just like I showed you the website, you can go to the website. You can reach out to your team. Our team will be happy to help you. And you guys can be part of our team. It's a growing community of space enthusiasts. It's a growing community of learners. Across India, students are learning. Students are building satellites and learning. So you can also be part of it. And I welcome you here. Okay, so if you guys are really interested, you can refer the website and you guys can join Nawars EduTech for the online courses or other anything. Okay, as you wish. So I hope the session was very clear for you. You enjoyed the session. You learned a lot of things. Okay, so we discussed a lot of things about the future missions. I hope it was clear for you. So the future is awaiting you guys. The future is awaiting your innovations, your contributions. You have to contribute. We'll be there to help you at any time. So until then, it's bye from me. So thank you guys. Thank you for joining. So shall we wind up the session for now? Bye guys. Thank you everyone. We'll meet some other day, some other time. So have a nice day. Bye.